The essence of mathematics is not to make simple things complicated, but to make complicated things simple. I'll repeat this again. The essence of mathematics is not to make simple things complicated, but to make complicated things simple. My name is Nira Chamberlain, and I have, some people describe me as an all-rounder mathematician. You know, I have different mathematical disciplines. I work in the corporate world as a mathematical modeling consultant. I'm a visiting professor at Loughborough where I do my mathematical research. I also go into schools and do talks as a science communicator, and also do some media things. But the essence of mathematics, that's what's the thing that actually ties all those things together. But when it comes to social justice, I have to tell you about my journey. Now, my journey actually started on the 20th of August, 1990. I was living in America, yeah? And this was me when I was 21 years old. I was living in America. And what happened? I came across a new verb. And the new verb was called to be MC Hammered, yeah? Now, for those who don't remember who MC Hammer was or is, he was a global superstar, you know. He was a rapper and a wonderful dancer, yeah? So some people may think to be MC Hammered means that you could dance really good, or some people may think MC Hammered means that you get drunk. No. To me, this new verb actually meant this: to share positive equality, diversity, and inclusion statistics that does not reflect the lived experience of the underrepresented group. I repeat, to share positive equality, diversity, and inclusion statistics that does not reflect the lived experience of underrepresented groups. So equality, diversity, inclusion, well, what is that all about? Well, I will read this statement in like a legal statement. According to the Chartered Institute of Personnel and Development, promoting and delivering equality, diversity, and inclusion in the workplace is an essential aspect of good people management. It's about creating a working environment and culture which every individual can feel safe and a sense of belonging and is empowered to achieve their full potential. However, organizations may increase diversity of their workforce but may be missing out on policies that ensure employees have access to opportunity to progress their career. Okay, we all mostly agree with that, all fine, yeah, that's equality, diversity, inclusion, but if you have been watching the news lately, no. No. We have a president in the White House, yeah, who has been looking, so over in America, of course, EDI is not called EDI, it's called DEI, they just swapped it around. But certainly EDI or DEI, whatever you want to call it, is under attack, And what you have is that you have the president writing some executive orders ending certain programs to do with EDI. But also before that, before you even got into the White House, what you had, there was this poll that showed that really truly 87% of C-suite executives, they were uncomfortable about EDI policies. So, but that was in the United States. What about the United Kingdom? Quoting this person, Victoria Jones, who is actually a global vice president for equality and diversity inclusion for a multinational engineering corporate firm, she's put this on social media. And she said, according to research on the London Herald, there is a disappointing downturn of diversification of boardrooms in the UK. It is thought many companies have met targets, so are now relaxing their approach. If this is the case, it would imply the culture has not changed in these companies at all, and diversity was just a box-ticking exercise, which is particularly worrying. So that is EDI, but really and truly, science is also under attack. You know, we have this gentleman here, a friend of mine, is a Professor Kit Yates, and he said, this failing to act the risk of emboldening those seeking to exert political control over science. Now, this is 2025. But 5 years ago, the world was so much a different place. It was very much a different place. You know, we had 2020, COVID had come onto the shores, yeah? And we was actually reliant on scientists, you know, advice and their insight and saying, how can we actually tackle, you know, this global pandemic? But also what happened was, in 2020, was the death of George Floyd. You know, because we was all locked down, it was there on our TV, was watching this injustice taking place, and there was a shock right across the world. So in 2020, the world was different. But let me tell you something else that happened in 2020. In 2020, I became the first black president of the Institute of Mathematics and its application, yeah? No. Good. Right. Okay. Now, the decision for me to become president of the IMA, as it's called, occurred 2 years before, yeah? And really, I was honored to be president of the IMA because when I looked at the past presidents, there are these esteemed, eminent mathematicians. The gentleman on the left, his name is Sir Lighthill. He was influential in designing the plane Concorde that could fly from London to New York in 4 hours. No plane can touch that right now. Do you know what I mean? And then you got other mathematicians there, eminent mathematicians who, was in the World War II effort and was to do with the flood barrier, the 10th flood barrier, and to do with cybersecurity. So these are eminent mathematicians. And the current president of the IMA is Professor Hannah Fry, and we all know who Professor Hannah Fry is. Yeah, very good. So, but one of my roles as president, when I was president, was I get invited to certain committees or get invited to Parliament to hear my expert view. And so I was invited to go to, virtually of course, to an all-party parliamentary group for diversity in STEM. So I was there and I'm thinking, yes, and there was all these other experts, from the STEM region who were there virtually. And one of the points that was raised was this, that they're saying that the Eckman's witness said that the EDI, statistical key performance indicators produced by corporations, etc., do not reflect the lived experience of underrepresented groups. And I thought, wow, wait a minute, that's interesting. Wait a minute, this is what all of these expert witnesses are saying. They're saying that when it comes to equality, diversity, inclusion, statistical KPIs, there are a number of statistical KPIs, they do not reflect the lived experience of the underrepresented groups. And I thought, wait a minute, this is bringing back memories of me living in America in 1990, to be MC-hammered. So I was thinking, wait a minute, now they're talking about statistics. Now I'm a mathematician. Can I just look into this? Can I actually look into this? So what I did is I started some basic background research, yeah? So that's what I did. And basic background research, right? Basic background research. Now, there is this BBC comedy drama called Death in Paradise. I like Death in Paradise, My parents are from the Caribbean, and it's so nice watching Death in Paradise, yeah? And Death in Paradise, whoops, here we go. Death in Paradise, right? It's based on a fictitious island called Sainte Marie, which is around about 160 square kilometers in size, and its population is soon to be around 10,000, yeah? Most of them are of African diaspora, black. So, but in this island of Sainte Marie, there is this unique elite police force unit headed up by a certain detective. And over the first 10 years, this genius police officer named Richard, one of them was named Richard Poole, then he got replaced by Humphrey Goodman, and then he got replaced by Jack Mooney, then got replaced by Neville Parker. Can you see what the pattern is here? Yeah? Can you see the pattern? I did a presentation once and said, can you see the pattern? And they would say, oh, they were wearing jackets. No. Can you see the back? Can you see the pattern? See, Sainte Marie population is soon to be 10,000, most of them being of African diaspora. But the genius police officer happens to be a white male. And this has been happening for the last 10 years. This has created some criticism. We had this journalist who wrote about saying, really and truly, she feels uncomfortable about this, saying, isn't this like a real throwback to back on era? And then this person saying, another journalist talking about Death in Paradise, leaving a sour taste in their mouth, talking about this idea of, let's say, a white savior, somebody coming in, surely the people in Sainte Marie are not good enough or not cannot solve their own problems. They need this white savior to come in. However, I still thinking, I still like Death in Paradise because I find it entertaining. And also, the next genius police officer, was actually Mervyn Wilson, who was actually brought up in Britain. But that's cool. But, however, despite this being entertainment, this actually is modelled on a real-life situation in the West Indies. It's actually modelled on a real-life situation in the West Indies. This is the West Indies cricket team in 1928. The West Indies cricket team in 1928 started to play Test cricket. And the question is, guess which 3 players will become captains and which 8 never will be? Here we go. I'll say again. Guess which 3 players will become captains and which 8 never will be? Any hands? Okay, let me have a guess. Oh, yes, it's correct. All right. So, that would happen. So, for the first 20 years of Test existence, the West Indies cricket team was captained exclusively by white players, despite the West Indies being a series of predominantly black population countries. But someone's saying, okay, well, actually, Nira, that was in the 1920s, and the 1920s was a different world. Surely nearly 100 years later, what's the problem? Surely things have moved on. Right. 100 years later, Let's look at the 2020s, and let's just pull out some random statistics from social media, from newspapers. And you can see there, football managers, of black former players, it's all about snakes and no ladders. BME people hold just 4.6% of the UK's most powerful roles, Unemployment rate over twice as high for BME workers than white workers. Black women are missing in the UK's top 1%, I can go on, and go on, and go on. And there was this boxer, and his name was Muhammad Ali, and he came onto a program one time, I think it was called Parkinson, and he said this famous quote. He says, "Why are the angels in heaven all white?" Why are all the angels in heaven white? Why aren't there no black angels in heaven? Why are all the angels in heaven white? Why aren't there no black angels? Now, if I go and look at through these number of these religious books and see there's those pictures, it's quite right. All the angels are white, and there are no black angels. So he actually did pose that question. But even though that may sound comical, there is a more down-to-earth but still uncomfortable questions. So we're saying, why are all the geniuses predominantly white males? Why are CEO, board members, captains of industries, corporate leaders predominantly white males? And we see this cartoon here, very much saying, diversity is good, pass it down. Diversity is good, pass it down. So I'm coming back to this and saying the all-party parliamentary group, we had a number of these different individuals, and they wasn't just talking about race, they was talking about other underrepresented groups. And they're saying these statistical KPIs do not reflect the lived experience of underrepresented groups. And what there was, again, doing the research and exploring it more, is the approach that tends to be taken is a very much a subjective an approach. They're saying, it's not about the numbers, move away from the numbers, let's go down this subjective approach. And there's been certain criticism of EDIs. It's saying that there's a lack of standardized metrics that can cause confusion to the business world. There's not a standard way to measure EDI. There's not a standard way. And they're saying, and those people saying, look, why are we doing all these questionnaires? Why is it doing all this tick box? And then when I look at this, and I'm saying, actually, this word, equality, diversity, and inclusion, Let me do this quote. Diversity is being invited to the ball. Inclusion is being asked to dance. Equity is being asked to dance when nobody's watching. Guess what? That's well-meaning, but it's not useful. So this saying, equality is everybody getting a pair of shoes. Diversity is everyone getting a different type of shoes. Very, very, very interesting, very well-meaning, but it's not helpful, yeah? I'll do this. What you're actually saying, when you're taking something subjective, when you're treating EDI as a subjective subject, you're making it complicated. And then the more complicated you make a subject, the less likely you are going to solve it, yeah? And what you're having is that you have inconsistency with definition, inconsistencies of what they keep swapping the terms around. They're making EDI too complicated. So, and this is where it comes back to what I said in my first slide. The essence of mathematics is not to make simple things complicated, but to make complicated things simple. So I was thinking, well, there's me. I'm at this, I've done my basic research, I've done this APPG, and I'm thinking, well, all of these people in this room virtually are from STEM, and we use STEM in our day job. And I said, I'm a mathematician, that's my day job. So really, what happens when we actually treat equality, diversity, and inclusion as a science problem? What can we actually find out? So, first thing is, let us treat EDI as a science problem. So, one of the things that we know is that every science problem has a baseline, yeah? Every science problem has a baseline. So, temperature has a baseline, weight has a baseline, noise has a baseline, yeah? And the nice thing is about science is that there's a consistency of definition, yeah? The consistent definition, a weight is a weight, yeah? Noise is a noise, temperature is temperature, and we have some sort of consistency definition. That is what was lacking when we're talking about equality, diversity, and inclusion, if we're doing it in a subjective manner. But let's just focus on the baseline, yeah? So the question is this: if EDI had a scientific baseline, what would it be? And I came up with this statement: if all things are equal, what number do we expect to see? I say again, if all things are equal, what number do we expect to see? So what I'm going to do is I want to consider a coin thought experiment. So let's say we have a selection of coins. So I have a British coin, so I've got £1, £2 here, and I've got a 50p here. So let's say I had 100 coins. Let's say 50 of them are British and 50 of them are foreign. Now let's consider the British coins. It doesn't matter whether it is £2, £1, 50 pence, 10 pence, 5 pence. The probability that when I toss it, it will land on a head is a half, yes? Now let's consider the foreign coins. Now the foreign coins will have its equivalent. See, I've got some US dollars here. Yeah, there you go. If you consider the foreign coins, yeah, it will have its equivalent of heads and its equivalent of tails, yeah? So the probability of it tossing it and it landing on the equivalent of its head is also a half, yes? So we have those 100 coins, and it doesn't matter, for those foreign coins, it doesn't matter whether it is American, Jamaican, Nigerian, Indian, Canadian, Filipinian, you know, the probability that it lands on the equivalent of its head is a half, yeah? So let's say we have those 100 coins. 150 of them are British, 50 of them are foreign, and I'm tossing them one by one. And if it lands on its head or equivalent of the head, what I'm going to do is I'm going to put it in the top drawer. And if it lands on its tail or the equivalent of its tail, I shall put it in the bottom drawer. So I'll do that, go through those 100 coins, 50 of them British, 50 of them are foreign. And let's say at the end of the day, when I've done that task, I open up the drawer, and what I find is all the coins in the top drawer are British, and all the coins in the bottom drawer are foreign, yeah? So what you're thinking, I'm reading your mind here, what you're saying here is, well, that is a bit off, because the reason why you think that's a bit off is because of the law of probability. The question is, what would you expect to see? You would have expected to see half the foreign coins being in the top drawer and half the foreign drawers being in the bottom drawer, but what we got there was all the British coins in the top drawer and all the foreign coins in the bottom drawer. See, now, I've talked about that doing a thought experiment, But when you look at a corporate organization anywhere around the world, this is what happens. The higher you go up, the less women and people of color you will see. The less women and people of color you will see. So I've done that thought experiment, and it's the same in the corporate world. The higher you go up in the levels, the less women and people of color you will see. So just using, let's say, the law of probability, can we measure the effectiveness of EDI strategies? Yeah? Can we measure the effectiveness of EDI strategies? So based on this statement, if all things are equal, what are the numbers do we expect to see? And you know what? I'm going to call it Chamberlain's law. I'm claiming it. Yeah, Chamberlain's law. Yeah. So here we go. So Chamberlain's law. If all things are equal, what numbers do we expect to see? What does that mean? Yeah, it means that the probability distribution of an outsider group across a company's grades should have the same probability distribution as the insiders group across the same grades. Yeah, I say again, the probability distribution of an outsiders group across a company's grade should have the same probability distribution as the insiders group across the same grade. So again, if we're talking about gender, if we're talking on the left-hand side male, on the right-hand side female, if all things are equal, what numbers do you expect to see? Not talking about magnitude, we're talking about the probability distribution. You would expect the same probability distribution for gender across the grades, yeah? And again, if we're talking about for race, white on the left-hand side, BAME on the right, white on the left-hand side, BAME on the right-hand side. Again, not talking about magnitude, we're talking about probability distribution. You would expect to see, if all things are equal, the same probability distribution across the grades, yeah? And it doesn't matter about the shape of the probability distribution. What we're saying is that you will have the same probability distribution if we're talking about Chamberlain's law. So it doesn't matter whether it's exponential, uniform, normal, you're expecting the same probability distribution from the insider group, comparing the insider group to the outsider group. So the key thing is, and what I'm going to do, is I'm going to show you some practical examples here. And what I'm going to talk about here is mortality rates. Now, in the black community, there's a concern about the mortality rates of black women when giving birth. So the key thing is, if all things are equal, what numbers do we expect to see? And so, obtaining some data, this is what we'd see. Now, the blue is the actual mortality rates per 10,000 maternity, or 100,000 maternities, I should say. So you've got Asian women, black women, Chinese women. The blue is the actual. The red is what we expect to see. Now, what I'm going to do is I'm going to actually just focus on the black women. So what we're saying there is that, really and truly, if all things are equal, you wouldn't see 29 women dying. You would actually see 10. 10. That brings reality. Instead of saying twice as much, 3 times as much, instead of being 29 dying, there'll be 10 if all things were equal. Moving on. So, again, some public data. I'm looking at BAME academics, yeah? And what I'm going to be looking at is, I'm looking at the academics in 2020, 2021. And what I'm looking here is, this is the actual numbers of professionals, say black professors, black seniors, Asian professors, Asian seniors, mixed professors, mixed seniors, yeah? And this is the actual number, yeah? But if we apply the same probability distribution that you find in the European populace, in the academic, what would it look like if all things are equal? It looks like this. So I'm going to focus on black professors for the moment. One time, I think it was a year after this, the number of black professors increased from 160 to 165, and a lot of people were celebrating, thinking that's good. But if all things are equal, that number will be closer to, I can see, 587. If all things are equal, that is the scientific baseline. Yeah? If all things are equal. Moving on, female academics, yeah? Again, we're looking at the actual numbers. The actual numbers are female professors, female seniors, yeah? And again, if all things are equal, if we do a comparison, if they had the same distribution as the male, what would you say? Yeah? That's how many female professors that we would actually see, if all things are equal, yeah? So now, I managed to obtain some results from, let's say, the BBC BAME report, and it's saying the BBC is committed to diversity aim at 20% BAME representation by 2025, diversity inclusion. Okay, so just going straight into it, what I have here on the x-axis is the grades A, B, C, D, E, F, and SL. Now, the higher grades is E, F, and SL. Now, the blue is the actual, and the red is the expected. Now, for the BAME people who are working for the BBC, from this report, if all things are equal, you can see that really and truly that they are more than expected in the lower grades and lower than expected in the higher grades. Yeah? You can see that there's a switch over at grade D. Yeah? Moving on. If we're talking about the females in the BBC, if we're talking about gender, again, a similar picture where you can actually see, more than what's expected in the lower grades, less than expected in the higher grades. However, if I do highlight this, this looks quite good. This looks quite good. Even though it's underrepresented, you see that it's getting quite close. So now, a way to actually measure inequality, so I'm coming up with these two statements, what I actually see and what you expect to see, and you can actually put that in a chi-square, do like a measure of inequality. And so, for instance, there I just looked at those higher grades for gender in the BBC and for the BAME in the BBC, and you can see for gender, the lower the score is much better. So you can see for females, it's much better than for the BAME. But what it means is by using the chi-squared is that we can actually measure inequality scientifically, yeah? Yeah, because we can actually say, this is what is actually happening, and this is what we expect it to happen if all things are equal. And then we can test whether those differences are statistically significant, yeah? And, but the chi-squared, there was a talk back in 2013 right here about the chi-squared. It's been used worldwide, but it has a controversial origin. Now, there was this gentleman, his name Carl Pearson. He is the one that came up with the chi-squared formula, and originally he was wanting to see whether there was differences in the races to prove that the European race was superior, and that's what he was invented the chi-squared to do. Now, amazingly, in 1909, he would have been standing right here. This is where he would be, right here. He was doing a lecture on embolism. He would have been right here, yeah? So, this is, that's Carl Pearson. But, for me, yeah, I'm using his formula to promote equality, diversity, inclusion, yeah? I mean, there's some people saying, oh, we shouldn't be using it. But if we can use it to promote equality, diversity, inclusion, yeah, I'm happy with that. He may not be, but I'm happy with that. Yeah? So, here we go. Here we go. So, let us treat EDI as a science problem. Part 2. Here we go. So, now, there's a question here. Diversity targets. Diversity tends to be the go-to main thing that people go for. But what I wanted to do is I wanted to show you a small video called Talent is Equally Distributed and Opportunity is Not. The career teacher said to me, well, Nira, what would you like to be when you grow up? And I said, oh, I don't know. I'd like to do something that involves mathematics and logic. And the career teacher said that, Nira, somebody of your physique, you should become a boxer. I thought, a boxer? And they said, you should become a boxer. And I do remember a number of years later when I wanted to do a PhD. I walked into a room, I saw this professor of mathematics, and he just looked at me, and the first thing he said to me was, Nira, you are technically weak and naive if you ever think you could do a PhD in mathematics. And moving on even a number of years later with my son, when my son was 4, and he went to infant junior school, and the teacher said to him, to my son, what would you like to be when you grow up? And my son said, oh, he wants to become a mathematician. And the teacher said to my son, oh, you'll never become a mathematician, but you might grow up to become a singer. Now, the reason why I'm saying all those things is that talent is uniformly distributed, but opportunity isn't. And one of the things I would like to say to answer that question is, you know, one of the things that also that my father actually said to me at an early age, and I didn't really believe it to him until I got later, until I heard what happened to my son, was that I don't need anybody's permission to be a great mathematician. Now, I know there's engineers in this room, so let me change that here. You don't need anybody's permission to be a great engineer. You don't need anybody's permission to be a great technologist, or you don't need anybody's permission to be a great scientist. But for me, you don't need anybody's permission to be a great mathematician. I don't know who that guy was, but certainly he can say some lyrics there. Yeah, you don't need anybody's permission to be, all right. So here we go, pipeline. See, a lot of people talk about, when they talk about EDI, they talk about pipelines. But guess what? Pipelines infers that talent is not equally distributed. There is a lack of talent the higher you go, yeah? So talent, look at this, people. Dr. Ale Folian, Dr. Nike Folian, Dr. Hayes Silim, who's CEO of the Royal Academic Engineering, Professor Anush Shah, who is was the past president of the Institute for Civil Engineering. The two individuals at the top were the founding members of the Association for Black and Minority Engineers. These are talented people. Is somebody going to tell me that, really and truly, that somebody there's nobody 90%, 80%, 70%, there's no bow wave behind them? No? And one of the things that I do is that I'm the chair of what's called the Black Heroes of Mathematics Conference, and we run that every year during October. And what we do is, the vision of the conference is to celebrate the inspirational contribution of Black role models to the field of mathematics and mathematical education. And that's what we did. Now, but when we started this in 2020, a number of the comments were said to me were, well, really and truly, you're going to find, worldwide, you're only going to find 8 black mathematicians, and that's it, you're going to run out. 8 black mathematicians, then you run out. 8 black mathematicians, oh, no. The key thing is, the more I look, the more I find. The more I look, the more I find talented black mathematicians all around the world, yeah? See, if you don't look, you will not find. And it's almost like saying this word about pipeline. Let me just use the Back to the Future analogy. I don't see my great-great-great-great-great-great-grandson and granddaughter coming to me and saying, hello, great-great-great-great-great-great, I forgot it right, great-great-great-grandfather, we come into the future and we saw you talk on YouTube in the future and we thought it was okay. No, that hasn't happened. Why? Because there's no pipeline. There's no pipeline. Moving this into the past, I use the example of the Windrush. Now, the Windrush, yeah, came from the Caribbean in 1948. It didn't arrive 48 minutes ago. Now, in that last 75, the question is, there were doctors, engineers, and scientists on the boat that came off that boat. Where are they? Where are they? Where are all those doctors, engineers, and scientists that came off the Windrush? Where are they? Yeah? There's no pipeline. And that's just one example. And there's more examples of examples around the British Empire, the Commonwealth, yeah? So the problems remain, this endless loop, and we've already seen this slide about this statistic. Now, the way that they talk about solving this problem is by means of creating diversity targets. Now, certainly when corporations create these diversity targets and they get close to or meet the diversity targets, this is the typical response. Yeah. You know what I mean? So, and they say, well, we've hit our diversity targets, or we're close to our diversity targets, and here's the message, and I have to say, yeah, stop. Why is this empty-hammered? Yeah. Now, The reason is, again, what I'm saying is, talent is equally distributed, but opportunity is not. So where is the diversity? Now, I will quote Lord Kelvin, mathematician, scientist, engineer, I will quote him. And he says this: if you cannot measure it, you cannot improve it. I say again, if you cannot measure it, you cannot improve it. So let's say, for instance, if I'm driving a car at 30 miles per hour and I want to know that I'm running out of fuel, do I look at the speedometer or do I look at the fuel gauge? See, the question with diversity targets is, it may be interesting, but is it the wrong measure? Is it the wrong measure? Yeah? So I'll give you a lesson from the medical field about relative risk. Let's say you have two groups, a group of men and a group of women. Now, I got this statistic from America, cancer among men and women in the USA, and they're saying 1 in every 2 men and 1 in every 3 women will get cancer sometime in their lifetime, yeah? We hear that statement over and over again from the medical field, like that, but we don't hear this, the equivalent statement, 66% of cancer cases are men. You see, that statement is a measure of diversity. This statement, 1 in every 2 and 1 in every 3, is actually a measure of equality. One is a measure of diversity, the other is a measure of equality, and the 1 in 2 and the 1 in 3 is actually called the risk probability. It's called the risk probability. So let me just go further and do it into a corporate setting. Let's say you have a company called Company XYZ, yeah? And you have 2 groups, Group 1 and Group 2. And you have upper grades, you have lower grades. Let's focus on the upper grades. So let's say Group 1 has 70 people in the upper grade, and Group 2 has 30 people in the upper grade. So the percentage of people in the upper grade for Group 2 is 30%. But in terms of Group 1, the total number of employees for Group 1 is 350, but for Group 2, it's 360. And so henceforth, in terms of the total group, percentage of people from Group 2 in the total of company XYZ is 51%. Now, really and truly, what we can do is that we can actually let's say a little division of find what's the probability that somebody in Group 1 is in the upper grade and what's the probability of somebody in Group 2 being in the upper grade. Now, the red cells is a measure of diversity. That's what companies usually do, is a measure of diversity. What is in the green cells is what's called the measure of equality. Some people do that but don't realize what it represents, but that's called the measure of equality. And instead of being the risk probability, it's called the opportunity probability. It's not a risk to get into the upper grade, it's more now the opportunity to get into the upper grade. It's called the opportunity probability. There's something called relative opportunity, is when you divide the 2 opportunity probabilities together, yeah? It's called the relative opportunities. See, now, here we go. When the opportunity probabilities are equal, it is called, again, when the opportunity probabilities are equal, it is called, equal opportunity. Equal opportunity. We don't hear the words equal opportunity anymore, but it's equal opportunity. Guess what? We have a scientific definition of equal opportunity. And equal opportunity is when the opportunity probabilities are equal. A scientific definition of equal opportunity. Yeah? Or we can look at the legal statement, the Equality Act, and you can read on it on and on and on about equal opportunity. But let me say this. I'll give you an example. I can say, right, I can write a letter and submit it to my solicitor and say, I, Nira Chamberlain, I am 10 feet tall and I weigh 5 stones. And that's a legal document, yeah? Any company can say, legally, we are an equal opportunities employer. I can say, I'm 10 feet tall and I weigh 5 stones. I can submit that to the solicitor. That's a legal document. Here we go. Then somebody will come up and say, Nira, let me measure you, and Nira, let me weigh you. Yeah? Yeah? What does the science say? Does the science say that I'm 10 feet tall? Does the science say that I weigh 5 stone? I'm not telling you how much I weigh, but does this, yeah? Equal opportunity, we can measure it scientifically, yeah? So how does this scientific measure relate to diversity targets, yeah? Because we're always talking about diversity targets. I did a simulation. On the x-axis is diversity targets. On the y-axis is a large scale of relative opportunity. The blue dots is where you actually miss equal opportunity. Orange dot is where you hit or exceed equal opportunity, yeah? And yeah, you can see there's quite a bit of uncertainty there, but summing it up, what you have there is, given a diversity target, what is the probability of delivering equal opportunity? See, now what you have there is, if you have a diversity target of 10%, you only stand like a 2% chance of hitting equal opportunity. If you have, let's say, a 30% diversity target, you only stand just like a 21% chance of hitting, achieving equal opportunity. But this is the strategy that most corporations around the world are using: diversity targets, diversity is good, and pass it down. So the question is, if you hit, let's say, 10% of your diversity target, why are we celebrating when there's only a 2% chance of achieving equal opportunity? If your diversity target is 30% and we hit it, but there's only a 1 in 5 chance of achieving equal opportunity, why are we celebrating? Why are we celebrating? Yeah? Is diversity targets the right measure? On the left is your diversity target. On your right is your opportunity probability. One is much more of a definitive predictor of how far you are towards equal opportunity than the other. Diversity targets have so much uncertainty. Opportunity probability is much more certain. And guess what? The mathematics is not complex. You don't need a PhD in mathematics to work out the opportunity probability. A primary school child could do it. Yeah? All I'm doing is simple division. The data already exists. All I'm doing is dividing one number by the other number, and there it is. Yeah? So bring back equal opportunity. Looking at the Equal Opportunities Act, it talks about there a chance to apply, a chance to train, a chance to... That is all about the law of probability. So why are we divorcing science from equal opportunity? Now, what I'm going to do is introduce something called the equality RAG matrix. Now, in the corporate world, a RAG matrix is a visual tool that often is used in project management and risk assessment that uses a traffic light system, red, amber, and green, to quickly assess the status of a risk level or different elements of a project, yeah? So what I'm going to do is I'm going to create what's called an inequality RAG matrix, and I'm going to apply it to the previous parliament, yeah? And so this is the equality RAG matrix, yeah? So what we have is we have the blue cells that represents the opportunity probabilities, yeah? And what we have is that we have red, amber, and green represented its significance. So for instance, when we're doing a comparison, the first one said BAME males in comparison to BAME females, you can see that literally there's a minor underrepresentation of BAME male MPs to BAME females MPs. If you go down, white females comparison to BAME females, you can see that there's a minor overrepresentation of white females, yeah? But in terms of black male, it's a major overrepresentation of white females. And when you talk about white males, across all the groups, you can see there's a significant overrepresentation of white males MPs in comparison to BAME females, BAME males, and white females. So you can actually see, something at the high level in terms of this red, amber, and green, but also you can go down to the detail. And again, the mathematics isn't complex, but can tell you where your company, where an organization is, and can actually track the effectiveness of your EDI strategies. So this was really, and also, let me point out that equal opportunity is when the relative opportunity is equal to 100%, yeah? So these are the MPs in Parliament prior to 2024, and we can do something similar for the BBC senior grades E, F, and SL. And as you can see there, for instance, blacks in comparison to whites, you can see that there's a significant underrepresentation of let's say, almost 57%, yeah? And again, we can look at another company, Network Rail Management in 2022, and here you can actually see, while looking at there, we can actually see with Asians in comparison to white and black, you can see that there's a significant overrepresentation of Asian managements in Network Rail. Yeah? So you can actually choose what groups and do the comparison, and you have this equality RAG matrix to see where your organization stands in terms of equality. Again, we can something similar for the NHS. So let me say that diversity targets, though interesting, will not guarantee you equal opportunity. Yeah? Diversity targets, though interesting, will not guarantee you equal opportunity. Diversity targets are not the strongest predictor of equal opportunity. Opportunity probabilities are. Yeah? And opportunity probabilities, as well as diversity measures, are needed to measure the effectiveness of your EDI strategy. Yeah? So why are we keep on talking about diversity, diversity, diversity? Yeah, talk about diversity, but you need the equal opportunity. You need to work out opportunity probabilities. You don't need a PhD in mathematics to do it. A primary school child could do it. And I'm going to quote this business guru, and his name is Peter Drucker, and he says this: you can't manage what you don't measure. Do we measure and report opportunity probabilities? Yeah? Do we measure and report opportunity probabilities? Again, if you can't measure it, you can't improve it. If you can't measure it, you can't manage it. So if we don't understand it, we can't measure it, and hence you can't manage it, nor can we change it. How can you move from the picture from the left more to the picture of right? Yeah? Irrespective, I know I focus on race and gender, but there are other protective groups, do you know what I mean? Yeah? Which you can apply the same method to, But let me say this. Let me say it 3 times. Diversity does not equal equality. I say again, diversity does not equal equality. Diversity does not equal equality. Yeah? And I will use a geopolitical example. South Africa during the apartheid era, yeah? South Africa during the apartheid era, yeah? Was it a diverse country? Yes. Was it an equal country? No. How did they resolve apartheid? Did they resolve it through diversity, or did they resolve it through equality? They resolved it through equality. So why are we focusing on diversity and ignoring equality? So, I don't know if you can make me out in the middle of the crowd there. Yeah, I went to an association for Black and Minority Engineers, Live 24, and there was this, in the crowd, the delegates were all scientists, engineers, mathematicians. This gentleman, his name is David Lusuga. You know, he's a historian, he appears on the BBC. He's a historian, yeah? He does history, art, he's doing history, yeah? And this is what he said to a bunch of scientists and a bunch of engineers and a bunch of mathematicians when it comes to equality, diversity, and inclusion. He says, stop normalizing the statistically abnormal. This is somebody from the arts, somebody outside STEM, telling us mathematicians about statistics, telling us engineers about statistics, telling us scientists about statistics. He gets it. And his art, his history, yeah, he gets it. We're scientists. Why don't we use what we do in our day job to resolve this? He gets it. He's a historian. Do you know what I mean? And it comes to this coin thought experiment. Though there's a possibility that all the British coins will be on the top and all the foreign coins will be on the bottom, it's still a statistical abnormal, yeah? And we see this in organizations up and down the country, yeah? But we normalize it. It is statistically abnormal. So statements about EDI, this was never about the pipeline. Think about the Windrush. It arrived 75 years ago. Where are the doctors, scientists, and engineers? Yeah? Again, this was never about subjectivity. How many times do I go to a conference, to a science conference, and I'm saying, let's talk about EDI, and they're using the subjectivity, they're abandoning the numbers and replacing it with questionnaires? We're scientists, we're engineers. This is what we do in our day job. And guess what? EDI has always been about this, the law of probability. It always has been about the law of probability. Always has been, always will be. So, last year, I sent a proposal to the all-party parliamentary groups because they wanted to do a new investigation. And they decided, and they voted on it, and they actually approved of my suggestion of saying, can we look at the way we look at EDI strategies? And they got me to write a blog about them. And I saying, look, can we use a scientific approach? So, but yes, in 2020, the expert says these statistical KPIs do not reflect the lived experience of underrepresented groups. Yeah, that's how it started. But the question is, how is it going? I was actually invited back to give evidence to Parliament 10 days ago, yeah? And it was good to hear the other experts coming together. And one of the things they were saying was action over optics. Action over optics. Optics is another word for MC Hammer, yeah? So, and, what he did say there was, and then they wrote a report, a blog, they're saying, bring back equality of opportunity. Mathematician Professor Nira Chamberlain was a guest. And he says this, Lord Kelvin, if you can't measure it, you can't improve it. If we're measuring the wrong thing, then we will do the wrong intervention. We'll do the wrong intervention if we're measuring the wrong thing, yeah? Now, later on this year, my paper will be produced, treating equality, diversity, inclusion as a scientific problem. But what I've been saying, and I'll be saying it over, is that equal opportunity is a scientific term and it can be measured scientifically. Equal opportunity is a scientific term that can be measured scientifically. So, on the 20th of August, 1990, I was living in America, yeah? And why is that date significant? Because this date was actually the beginning, I didn't realize at the time, was the beginning of my journey, of a mathematician's journey to social justice. Why on that date? Because on that date, I watched a certain program called The Oprah Winfrey Show. And on it appeared MC Hammer. And he said this, and he was talking about the plight of black people in the United States of America. And this is what he said. Things are not that bad, yeah? That's what he said. Things are not that bad. And I remember the audience all applauded. I thought, wow. And then I read this statistic. Things are not that bad. Black mortality rates were higher than those of white individuals, with black adults aged 25 to 54 having more than double the mortality rates of white groups. And this is down to poorer access to healthcare, poorer living conditions, excess discrimination and stress. Things are not that bad. So, a new verb, to be MC hammered, means to share positive equality, diversity, and inclusion statistics that does not reflect the lived experience of underrepresented groups, because by doing that, you'll go for the wrong intervention, yeah? And you will not know exactly where you are standing. In conclusion, talent is equally distributed, but opportunity is not. We have to measure equality, not just diversity. There is a difference. There is a difference. And if you don't think there is a difference, think about South Africa during the apartheid era. Because measuring equality is the strongest predictor of equal opportunity. Equal opportunity. So, I started it like this, and this is how I end it. The essence of mathematics is not to make simple things complicated, but to make complicated things simple. And that's what this is what my aim, always my aim in whatever I do, whatever mathematical job I do, my aim is to make complicated things simple. So, let's stop being MC hammered.